Good morning, all. We'll just give people a few moments just to come in. Good morning, all, and you're most welcome to today's webinar on practical ergonomic risk assessment in construction. So my name is John Egan, and I'm an executive for safety and training with the Construction Industry Federation, the CIF. Today's event is brought to you by the Health and Safety Authority in conjunction with the CIF and the Irish Human Factors and Ergonomic Society. So I guess the learning objective of today's event is for all participants to possess an understanding of the practical risk assessment tools readily available for quantifying ergonomic risk, and then to have an appreciation of the importance of controlling risk through the introduction of innovative engineering solutions, or by simply changing the way work is planned and organized. So we're joined by a panel of experts who will introduce in turn. But before we begin, there's a few housekeeping rules I'd like to run over. Through the chat function, there'll be a number of links shared with you. The first will be the EU OSHA link, and that is around the healthy workplaces. As we know, next week is European Safety Week, and there's a whole suite of resources available. And of course, the theme is on musculoskeletal disorders. The second being the MAC tool link. So Frank will detail this in his presentation shortly. And thirdly, just to bring your attention to the Health and Safety Authority's webpage, and there's a whole section dedicated to ergonomics on that. The next part is around questions and answers, just to say that there is an opportunity at the end of the three presentations. So we would encourage people to please enter any questions you may have using the questions and answers window on your screen, or the Q&A window, and we will address them at the very end. Just to say that today's event is being recorded, and the whole intent is that this will be made available then through the Health and Safety Authority's webpage next week for further referral. There will be also an online survey as part of at the end of the presentations, and of course this is to gauge your level of interest, and to try and pick up some pointers that can be adopted for forthcoming webinars. There will be a comfort break as well. So the event is scheduled to go on until 12:45. So Ita, during her presentations, will accommodate a 3-minute break, and that will just time to stretch the legs and take a break from your screen. So without further ado, I'll hand you over to the first your first speaker. Now it needs no introduction. Frank Power is an ergonomist. He's also an inspector with the Health and Safety Authority, and he's going to go through managing ergonomic risk with current strategies and interventions. So for those of you that don't know Frank, he's been involved in the HSA as a inspector and project manager, and since joining the authority, he's been involved in addressing ergonomic and manual handling issues at a strategic and workplace level, and has acted as an expert witness in the courts. So his main areas of expertise include development of regulations and guidance, completion of regulatory inspections to address ergonomic risk management issues, and he's represented HSA as on NSAI, EU and National Disability Authority work groups. So I'll hand you over to Frank.
Thank you very much for the introduction, John, and good morning everybody, and you're all very welcome to this event today. We're delighted you're all here. So I'll just kick off. This is just a quick overview of the Health and Safety Authority strategy and interventions with respect to managing ergonomic risk, particularly relating to manual handling. So without further ado, I'll just kick off. First of all, I'd like to just make the point that in relation to manual handling risk, there are a number of duties that our employers have with respect to managing those risks. First of all, they need to have an understanding of the manual handling activities taking place in their workplace, and particularly those activities where there is significant or potential risk. They need to be able to collect very relevant technical information, including information as basic as load weight data or information on work area setups, because that information will inform whether or not there are potential risks. They need to be able to use evidence-based risk assessment tools to identify risk factors, and that's really why we are here today, to learn more about the application of the two types of tools that are evidence-based that can be used to do this type of work. And they need to also, once they know that there is a potential inherent risk with respect to a manual handling activity on a construction site, they need to put measures in place, appropriate measures in place to address risk factors, including introducing lift equipment, changing how work is organizing, or reducing load weight specification. So all this really relates to managing ergonomic risk. So it requires a number of things. First and foremost, it requires a commitment from a contractor or a PSCS or a subcontractor that they're going to recognize that these potential manual handling risks may exist in the type of work they're doing on site. They need to ensure that those responsible for purchasing equipment and design workplaces understand the importance of addressing ergonomic risk from the beginning of a project. And this is very relevant for the construction sector because a lot of the impacts in terms of design will have a major impact in the construction stage. So if we can manage, particularly around manual handling, if we can address these risks at the design stage, all the better. We need to take steps to understand the nature of work carried out. That might sound basic enough, but I was on a construction site only last week, and these are the types of questions I asked with respect to different, I suppose, types of materials that I observed on site. I was asking questions around, well, what's your plan in terms of moving these from where they were located and installing them? So simple things like that are very important, particularly around manual handling risk. We need to ensure that people and employers and health and safety managers and health and safety officers develop competencies in managing ergonomic risk by using risk assessment tools such as the Health and Safety Executive MAC tool and RAP tool. We are recommending the use of these tools. Doesn't mean that you have to use them, but we would say that these are very user-friendly and they're evidence-based. So they're very simple to use. And then risk management requires innovative engineering or organizational interventions to be put in place. The importance of consulting with those that are doing the job, consulting with subcontractors, having a good appreciation of what's going to happen at different stages in the project and whether or not we're going to have a potential manual handling risk. Implementing appropriate changes in work practices and developing a RAM, a risk assessment method statement, which incorporates maybe changes in terms of how a task is carried out to alleviate or address ergonomic manual handling risk. And then most importantly, then providing the training for staff who are going to be doing that work activity on the ground. So the legislation I'm not going to talk about really, it's just to suffice to say that everything we're talking about with respect to managing ergonomic risk is all incorporated into our legislation. The 2005 Safety, Health and Welfare at Work Act and the Hierarchy of Controls, Principles of Prevention, they talk about the avoidance of risk, reducing risk, adapting work to the individual. They talk about providing safe systems of work and risk assessment. We have the manual handling of loads regulation, which are, requirements for all employers, whether they're subcontractors or the main contractors. We have the Safety, Health and Welfare at Work construction regulations and their duties in there with respect to designers and the PSCS and contractors, subcontractors. So all of it talks about risk management. If you look at all those regulations, at different aspects, they talk about risk management, they talk about avoidance of risk, prevention of risk to health, adapting work to the individual, using appropriate means, and evaluating unavoidable risk. So what I would say is that while it's important that people are made aware of, how to lift correctly, we need to understand that that is the last part of the intervention, that kind of intervention alone is not significantly effective. You need to be looking at how we can improve how jobs are carried out. And this is where I come from in terms of risk exposure, because one of the things that I think contractors and people on site who are looking after health and safety, if they're going to manage these risks, they need to have evidence of what planned manual installation of loads are going to happen on site. So, if we look at materials like this, well, what's the plan to get these installed? What weight are they? Are there inherent risks for people who will have to install those? So it's a good indicator when you look around the site to see what kind of materials you have: plasterboard, glazing, timber frames. All these are things that are on site, stone cladding, and then you've got modular materials that need to be put together and assembled. So all these materials have one thing in common: they could be potentially very heavy, they could be very large, they could be awkward to install. So you need to take account of that at a very early stage. And just depending on training alone will not deal with that. So when you look at those kind of materials that I just put up there as indicators of areas where you may need to look at risk assessment, yes, you have to ask yourself some questions. If you're doing a risk assessment of the manual handling task, what type of manual handling activities are carried out? where are loads going to be handled and what are the steps involved in moving a load, whether it's transferring it from ground level up to a loading bay, whether it's transferring from a loading bay through the scaffold area and installing. Have you information on the loads weight specifications of loads? This is something I've come across in construction sites a lot, and I think it is something that should be looked at, is to get more information from suppliers of materials on what exactly the load weight specifications are, because that information is very important to inform you whether or not there are risks in terms of the manual handling task. Can you provide documented evidence that ergonomic risks or manual handling risk factors are being managed and identified? So things like whether the load is too heavy, work posture, repetition, the work environment, safe access, egress, the floor, the quality of the flooring, trip hazards. All those factors are variables that can impact and potentially expose people to risk. Can you provide evidence that appropriate mechanical equipment is made available to handle heavy loads? Have you prepared a method statement or RAMS which outlines the system of work for installing heavy loads on site? So they're useful indicators and useful questions to ask when you go back to your site. So again, I'm not going to talk about the tools, but Ita will be talking about these in more detail later. But the MAC tool looks at lifting and carrying activities and team lift activities, and it's a very relevant tool for assessing manual handling tasks in construction. We've got the RAP tool, which looks at pushing and pulling, and then the R tool, which looks at activities where there's a lot of repetition of the upper limb muscles in doing a task. And you will have that from time to time on a construction site as well. So, I'm not going to go through this in detail because Ita will be covering this in a comprehensive way in a little while. But this is an example of a score sheet that would be developed for use of the MAC tool. And the big thing I was talking about earlier about risk exposure, we talk about measuring accident rates and illness rates, but they are only one measure of, or KPI, if you want to call it, key performance indicator. A real effective key performance indicator in determining whether or not you have manual handling issues or manual handling risk is to look at risk exposures. So this is an example of a score sheet for a particular work activity. And if we look at the color codes there, we can see purple, reds, greens, and ambers. So the reds and the purples are risk exposures for load weight and postures. So we know inherently that there are significant risks there and that need to be addressed. So this is the kind of thing that these are the kind of score sheets that would be very effective and useful for addressing these risks in a construction setting. Briefly, I just want to talk about the Health and Safety Authority. Over the last 7 or 8 years, there's been a lot more emphasis in the authority on an increased focus on managing health risks in the workplace. And in this strategy over the years, we've talked about increasing the knowledge and understanding of occupational health risks. For example, musculoskeletal injury, illness, ergonomics, raising awareness of the value of controlling these health risks and ensuring legal compliance through proportionate enforcement. So with that in mind, I, with my colleagues in the authority, have developed strategies around managing ergonomic risk, and we've developed a number of interventions. One of those interventions over the last number of years has been that all our inspectors in the field, the operational inspectors, have received training from the Health and Safety Executive of the UK on the use of the different tools, the MAC tool and the RAP tool. And the ultimate objective of that is that it's not that inspectors will be carrying out risk assessment on site, but it will be that they have the knowledge and understanding of what is a risk and what's not a risk. And it can give them an opportunity to pose questions to contractors or subcontractors or PSCS as to what's going on with respect to manual handling risks. Also, we've been doing these workshops and webinars since we started in 2017. So the objective of those workshops and the webinars today is to disseminate information around the application of these tools and to have it as a practical element so people can try them out. So I would urge you, the links that were put up by Barry earlier, the MAC tool link, and the link was there when you registered for these events as well. Have that downloaded when Ita comes on stream in a little while, because you get a better understanding then of how the tools are applied. The other things we've done is develop particular guidance documents, and the one in the middle there, the Managing Ergonomic Risk in the Workplace, this was developed in 2019 to complement the work we've been doing around disseminating information around the MAC tool and RAP tool. And within that document, I think it's page 15 to 18, there's very key information there of the risk assessment process, the 5-step risk assessment process, which can be applied and can be used in any sector and which incorporates the use of the tools into that risk assessment methodology. So I would, again, you know, that's available on our website, and the link was already sent to you, so you can look at that information. Other things we've been doing, and we will continue to do this, is to look at examples of good practice and document those case studies of good practice. So you can see one here in the manufacturing sector on the left, but you can also see one on the right, which is JJ Ratkin in the construction sector. And Emmett's going to be talking about this case study in a little while. And the case study is the main objective of the case study is really to disseminate the problem solving, the innovation, the I suppose risk assessment, and then the benefits in terms of what the solutions were, so that we can raise awareness around these approaches, so that, you know, we get more tangible work going on in settings like construction and others. So there's evidence there that these issues are being managed effectively. So from an inspection point of view, I suppose over the last couple of years, particularly the last 18 months, a lot of the focus has been with respect to COVID. But we had a strategy developed back in 2019, and within the construction sector, we were looking at working at high traffic management, occupational health in terms of respiratory dust and manual handling risk management, and also the duty holders. That took a bit of a sideline because of COVID, but I will mention while we're here now talking about this, that there will be a construction inspection blitz starting on the 26th of October until I think it's the 5th of November. And this will primarily focus on working at height, but also manual handling risk management. So it'll be looking at the kinds of issues we're looking at today, you know, the evidence that, you know, where potentially there's manual handling work activity going on, that you can demonstrate that you're managing those risks effectively. So finally, I'd just like to say, thanks again for coming along here today. I appreciate that. Don't be afraid to give feedback. I think give the risk assessment tools a shot. Introduce them to your PS, project supervisor for the design process, and others and subcontractors on site. But more importantly, take a step back and look at the kinds of work activities in your workplace on the construction site. Look at the kind of materials that you're planning to install at different stages of the project. And don't be afraid to look at our website. So that's it. Enjoy the webinar, and thank you very much. Thank you, John. Okay.
Thank you, Frank, for that. Thank you, Frank, for that. And I guess just to reiterate as well, as Frank mentioned, on the chat function, it has been shared a link to the Mac tool. So if you want to go in and it's a second link that's shared, and just access that, so you have it then for not necessarily for Emmett's presentation, but for Ita's that's coming thereafter. So next up we have Emmett Hines. So Emmett is the Group Health and Safety Manager with JJ Rattigan. Emmett is going to go through ergonomics interventions in the workplace, and he's going to focus on a case study in construction. A little bit about Emmett. I won't say how many years he's been working for JJ Rattigan, but it's nearing on 20. He is the company's health and safety advisor and performs the role of project supervisor for construction stage on behalf of the company on all the construction projects undertaken by the company since 2000. He has full control over implementing and auditing health and safety policies, procedures and policies within the company, and coordinates activities of in excess of 20 safety advisors, ensuring the continual improvement of safety, health and welfare within the company. And for the last number of years, he's been, piloting and working extensively with the Health and Safety Authority on focusing on musculoskeletal disorders and looking at engineering solutions. So I'll hand over to Emmett. Thank you.
Thank you very much, John. Welcome everybody. Good morning. John has outlined a little bit there in terms of this was an intervention at our place of work, and from this we have worked hand in hand with the Health and Safety Authority to create a case study that the Health and Safety Authority could use. So the main area, or the area that we're looking at, is stone cladding, and anyone that might be familiar with Galway, as you come in into Galway, there was a new Garda headquarters built there on across from GMIT on the Galway Dublin Road, and there's a picture of it there that as we can see, a lot of different facades, glazing and stone cladding. And in particular, we're going to be focusing on the stone cladding element today on this presentation. So I'm just going to go through a quick introduction with regard to what happened or what was happening initially. Then we had a HSA visit. And from that, we had to put in a process to ensure better safety with regard to the installation of the stone granite and limestone, both vertically and horizontally on this building. So we had to look at every single aspect of this, from the planning, from it being on site, on the ground, to how we actually install it onto it. So the full process had to be reviewed and extra controls implemented. And then we're just interesting conclusions with regard to this, not only in terms of health and safety, but also quality program, all the other buzz elements, I suppose, and key things that people are looking for in the construction industry. It has assisted all elements with regard to having a better process in play. I suppose firstly, we have to put our hands up as a company with our subcontractors that we didn't do things right. That's number one, and there's no point beating around the bush here. When we started this process, we didn't look at it sufficiently. We didn't put in the hierarchies of control. We didn't put in the general principles of prevention. We did appoint a competent subcontractor to come in and do the job, but we, as PSCS, didn't enforce mechanical means with regard to the actual installation of the stone. Yes, we had procedures in place for lifting the heavy material up close to the work area, but we ignored it after that, from the loading bay basically to where it had to be installed on the wall. We received a HSA visit and they weren't happy with what they saw. It's as simple as that. But I have to say, it could have been very easily that they could have issued us an improvement or a prohibition notice. However, they worked with us. The inspector actually called Frank, who was speaking at the beginning here, and Frank met with us, and we started discussing what we can do and work together in terms of what is the best way to make this safe for everybody and to get a proper system of work in play. Okay, so we were 100% wrong, but the Health and Safety Authority worked with us, and we came up with a system. And since this, we've used this system again that I'm going to go through, but we've also used the MAC tool that you'll be going through later on. And we've also got earlier design intervention with regard to stone cladding as well, which kind of is even eliminating the need for mechanical means, that we've reduced the size of the stone and things like that. So this is only one way, and this was, I suppose, a reactive way from a product that we have. And on current projects, we've had a proactive where we've redesigned it and stuff like that. So it's not just one way we can look at this problem. If we can get in there early enough, there's various different ways that we can do this. So from the Health and Safety Authority's visit, there was a couple of key things that needed to be done. We had to develop a prescriptive method statement. So there was multiple languages and multiple foreign workers that were working on this, and we needed to make sure that whatever we did come up with was going to get across to everybody. And as part of that, we set up what was, I suppose people are used to it now, an SOP. And we put in photographs. So every single stage, and we're going to see a lot, or a good few of these pictures that are in the slide were used within the SOP that we had. So every section was broken down, photographed, so that, you know, a picture paints 1,000 words. Everybody knew exactly what needed to be done. And we had to look at all the aspects with regard to that method statement, from when it was on the ground right up to being fitted on the wall, and the fact that there was vertical and horizontal stone cladding as well. It's not just the vertical. So all aspects of the installation had to be included in this. From having the descriptive method statement, it was key that we communicated, and the photos was assisting in terms of that as well. As I said, it makes it clearer for people to understand. Also, as part of this, the fourth element that I've underlined there is the placing of cladding upright on a two-wheel buggy. So, and what I actually should have lined there, the organizational measures needed to be put in place for this. So again, what we've tried to do, and I think we were successful in this, is that we have eliminated any element of stone having to be lifted by humans at any stage through the following process, the process that we're going to do. And the maximum that we have is a heeling and towing exercise, where we're just moving by heeling and heeling and heeling, that we're moving it a small distance to get to where we needed it to be put in place in terms of the additional buggies and trolleys that we used on the system. So just to give you an idea here, and to be quite honest, very frightening figures associated here. In terms of the granite, it's 60 mil thick, so over an inch, over 2 inches thick. In terms of the cladding sizes that was going to be put up here, and some of them ranged from being a height of over a meter to nearly 3/4 of a meter in width. And these resulted in weights of 142.2 kg max that's on this sheet, and we have gone a little bit higher as well. You can see that there is some smaller stone elements, 19.4, but there's a lot more there that's well over the 50 kg mark. We're heading for 80, 113, 116, 105, 142. So these are huge weights that realistically were being lifted by 2 people and way above what should have been done. In terms of limestone, that was even thicker. These were 75 mil thick cladding panels, and again ranging over half a meter one way and half a meter or a little bit more in the height or in the width. And again, we're talking 142 kgs. And I believe the next one that I have highlighted has gone up to 143.7 kg. So again, huge weights that no 2 people, no 4 people should be even lifting kind of weights that are in this range. Okay, so it was key that something had to happen and something had to change in terms of the processes that we were doing. It had gone beyond the point of design, really, in a sense. So we had to bring in extra controls and technical progresses, I suppose, with regard to it, if we link it back to the general principles of prevention with the introduction of mechanical means. However, that's only for lifting it. There are numerous other aspects that we need within the process also. So firstly, in terms of the process, we have part 1 is getting the stone to the loading bay and the working area and making sure that that's sequenced and undertaken correctly, and that the right stone is going up at the right time to be installed, so that there's going to reduce any maneuvering or getting unwanted stones out of the way or whatever else like that. So it had to be coordinated, planned, numbered, sequenced, so that the right stone is up at the right location at the right time. Scaffolding loading bay setup, and in fact scaffolding platform setup, so that we were distributing the load also, and I'll run through that when we see some of the pictures. And then we introduced some trolleys, so lifting aids and moving aids, to be able to get the stone from the loading bay to the designated area to install onto the building facade. And then we moved to actually installing it. So what we had to do is make custom-made bracket systems to allow us to be able to hang a pulley system and an Abaco lifter at the different positions on the wall. Again, you want to see them as we go through the slides. And then not to forget that there's also horizontal stone cladding to be positioned here, which would need alternative and different means of mechanical lifting and assistance to get that stone to the relevant section. So it starts when the stone comes in, and we need to make sure that the right stone is on the pallet or in the packaging that needs to go, and that this is what is needed next on the scaffold. So that's dropped and put in a position where we have trained slingers and banksmen that's going to lift this with the crane, or and in this case, on this job, it would have been tower cranes that were lifting this. So again, we test the load of this, even though we'd have a good idea, because now we know all the loads for each different stone. We know what the weight of this pallet is, but we would still do a test lift with the crane to ensure that he's capable of lifting it and bringing it to the location that we need. And just like any manual handling aspect that we would have, we have to assess our environment and ensure that we have a clear route for the load to be able to get to where we need to get to, as well as the banksman being able to get from this load to where it's going to be landed as well. So all of these aspects have to be brought in. And again, if needed, this needed to be broken down and the stone sequenced out for what was actually needed up at the work area, which could be various different sizes, depending on lintels, windows, and stuff that could be in the area. So these were specific to the locations of work. So the banksman follows its load and positions it carefully on the loading bay. We had to think about this. There could be movement while the load was in the air, potential of these stone claddings in here. So we needed to make sure the safety of the banksman and the guys that are going to be stripping this, stripping off the packaging from it, and ensure the safety of those in case there was any movement or pallets stone cladding moving or whatever in there. So you can just slightly see, and we'll see it in the next slide again, we set up a system where we had planks positioned at the intermediate handrail level, 500 mil, so that we could push or lean the pallet back to ensure the pallet or stone cladding wouldn't fall out towards the toes, I suppose, for the want of a better way of describing it, or towards the legs of those who would be working on that loading bay with the new pallet that was delivered up there. Okay? So every single aspect had to be looked at, and this wasn't thought of initially. We put it up, and there was a time, you know, when we were up there, that the guys would then come back and talk to us. Well, what if there was movement and this moved? There was a risk of injuries. So we introduced this. You know, this didn't happen overnight. There was loads of different processes, doing the different sections and adding new control measures each time as was needed. So we can see here then that we would lever it back, just tilting it back so that it was supported against them boards at the back, and to prevent, you know, it's going to potentially fall out and land on these individuals that would have been standing on the platform. We can see here with the loads, the loading bay was designed for it, but we have plywood on it. And again, this was linked towards the trolleys and ensuring that we were spreading loads, and rather than having point loads on individual scaffold boards, that we had ply on the loading bay and on the platforms. So the introduction of the first of two different types of trolleys that we used on it. So we'd remove all the packaging, we'd set up the trolley, lock the wheels in a suitable position so that then we could maneuver the first stone cladding, could probably easily just tilted over, left onto the trolley and maneuvered to get into centered on that trolley. As you get further back in the pallet, you would have to heel and toe that stone cladding to get closer to the trolley and then position it on it. So at no time were operatives or stone cladders allowed to take the full weight of the stone and remove it directly from the pallet. So to gently move it across, heel it and toe it as is necessary, and put it onto the trolley. Only allowing one stone cladding at a time on the pallet or on the trolley for distribution then. Here we can see that we've started to go along the actual working platform, which we can see is plywooded. Okay, that again is solely to prevent point loading from wheels on individual scaffold planks and to ensure a spread of load across the full bay of scaffolding. We did use two different types. This was one option. And then the second option, a more traditional type of trolley that you might see on sites. And again, it's used on a heeling and towing process, put onto the trolley, brought to the location that we needed it, and then it would be supported there against the standard or something like that on a short term. Okay. There was cantilever brackets on the inside, and I'll probably discuss that again shortly on it. That was implied because with regard to the stone cladding, it was not allowed to be left as a load on a cantilever bracket because it just couldn't take the weight. And again, we had to do temporary works design in terms of our cantilever brackets to allow two people to even work on an individual bay. And as a result of that temporary works, two people could work on a 3-board cantilever bracket once nobody was working on the two on the cantilever brackets either side of the bay that we were working from. And that allowed us to take the loadings from the neighboring cantilever brackets and allow two people to work on one section of that cantilever bracket system. So then we needed to be able to attach a block system. So how did we do that? We had to come up, firstly, I suppose, this is a concrete frame structure with a large parapet at the roof, which was a huge advantage for us. So we built a custom-made bracket system that fitted over the parapet that was able to hold our block and tackle system, for want of a better way of describing it, our Abaco system. This was certified, load tested and certified, along with the block and tackle system that we would have used. And you can see a blue tag there and a yellow tag here on the different systems that we had. So this allowed us to gain access to the full facade or the majority of the facade of the building down through the cantilever brackets. An alternative system that we had, so apologies, in this one here we would have to move it every after installation of 3 stone cladding elements, so a central one and a one to the left and to the right. A second and an alternative running beam, steel beam, was fixed and again certified to the structure, which allowed us to be able to run for a longer length. So up to 10-12 meters of steel is here, which made it easier, and rather than adjusting that top bracket that we looked at initially, we could just easily run for a longer length, installing each element of stone. So 2 different versions there that we used in terms of installing and holding our mechanical system. So then we get to what was at the base of these bracket systems and block and tackle, which is an Abaco lifting machine, which we purchased and brought in from Germany to do this. And this hung down through the block and tackle, and we had a scaffolder working with the stone cladders at all times to adjust and remove what was necessary with regard to the upper lifts, in particular on the cantilevered section. So this came down through the cantilever bracket system to the relevant lift of scaffolding that we were working on. And our block and tackle attached to this, and this is the Abaco system, which is a suction system. And what we would have is we had the operator of this on the upper lift, and ensuring that we had handrails in place because there was an exposure within the cantilever bracket, and we had 2 operatives or stone cladders on the lower lift, and that is the location of where the stone cladding would actually be installed. So this came down, and it would be brought back out to the main working platform, and it would be placed over the stone cladding to be put in place, keeping that stone cladding again off the cantilever bracket, as I have mentioned. There are just a couple of images of the system, and it slides in over it, and then the suction system, once activated, takes the weight of the stone. And then that brings the stone cladding to the location of the work, with 2 operatives simply guiding it and avoiding it hitting anything or anything like that, and not taking any weight of the stone cladding. Grips it and lifts it off the scaffold, and we can guide it into position. That's just taken from the user manual and the operation manual that we got for that system, and we worked in accordance with it. So any items of machinery, we would have the user manual, and we would have briefed that to all the operatives that were undertaking the use of that device. So it grips it, we bring it over, we place it into position. Again, the two operatives guiding it to ensure no damage is done to the cladding or to the building or to the scaffolding. And it's positioned in the relevant section. The guys would be using their knees. Again, they're not taking any weight, but they're just guiding it and moving it with knees and arms to get it into the right position. And then once it's in that position, they could remove the Abaco lifter, and they would install the fittings as is necessary then to fit it to the necessary location and use the proprietary fittings that was associated with that cladding system. So we saw one custom-made bracket system at the very top, and we came to a problem then that when we got near the top of the parapet, we needed extra height to be able to put that Abaco on. So a second custom-made system was bracket system was developed and certified and used, which just gave an extra bit of height so that we could put in the top rows of stone cladding across it. So when we thought we'd everything sorted with the couple of different systems we saw earlier, when we got to the top, we realized we had a problem again, and we needed a new designed system to be allowed to able to take the weight and carry the system to be able to install stone cladding. So, you know, with 3 or 4 different systems there in place, our mechanical systems between trolleys, a singular lower level bracket system, a running beam was used, and now we have a higher one at the parapet section. The second element then was the horizontal stone cladding that was required at certain locations around the building for these recesses and things like that. And for that, we brought in a double scissors lifting platform truck. And again, when that was on scaffolding to avoid point loads, we had the scaffolding plied out to try and distribute the load of this. So again, it'll be left at the lowest point. The stone would be heeled and towed onto that platform, and then mechanically lifted to the height that we would need. We usually put insulation underneath the stone to start with, so that we'd be able to shimmy and be able to shim it up a little bit and get the right heights for being able to fit it onto the relevant location on that soffit area. Again, we have an alternative and a new mechanical aid implemented here also. So in terms of conclusions, with what we brought in after going through this with the Health and Safety Authority, when we actually did the works, well, number one, as I discussed there, we actually eliminated manual handling for humans. Okay? Everything was done by mechanical means, and the only element of maneuvering was heeling and towing. We weren't taking the full load of the stone cladding. What should have been happening to start with, and we were PSCS, but we had better planning and coordination of the works off the back of this. In terms of the vertical work, we had improved productivity. So our program with regard to this increased by 25%. And in terms of the soffit work, which was extremely slow, painful and awkward work prior to bringing in this platform system, we increased that by 50%. We were able to reduce the numbers, as we saw in the photographs. We had 2 down below in terms of stone cladders on the lift that the cladding was put in, and an operator on the lift below, on the lift above. Originally, there was 4 and 5 person teams lifting this stone into place. So we were reduced even the resources that we needed. Yes, we also had to include a scaffolder. And the other element here was that we improved quality, because there was no longer, you know, manual handling or losing or dropping something and causing chips and damage to the stone cladding. So it improved the quality, because we weren't doing that anymore. This it was mechanical means all the way that had full control on the stone panel. So we eliminated and we improved health and safety. We improved program. We improved and reduced the resources that we needed on team, which is better, so there was less people exposed to potential risk, and it improved quality also in terms of the product itself. As I said, this was the first time we were kind of introduced to the MAC tool as well. We've brought the MAC tool now that we would do this at a very early stage on new jobs in terms of stone, and where we actually try and design out or reduce the size of the stone between thickness and the size of the panels to get it down to below 50 kg in weight, which we've been able to successfully do on another job in Galway. But if we're not in at an early stage, we now know different mechanisms and different ways that we can introduce mechanical means and ensure that that is done. And it has been a big eye-opener for us as a company in terms of more due diligence with regard to RAMs and our method statement risk assessment and the acceptance of what is included in it, and talking to our subcontractors at a very early stage in terms of these processes now to ensure that we're all on the same wavelength with regard to how we implement manual handling activities on our site, whether that's wall capping, stone cladding, brickwork, blockwork even, installation of lintels, as we saw earlier on there with Frank as well. I think questions is at the end, but if anyone does have any questions, please do add them in the Q&A section, and I'll try and answer them as best as possible later on. Thank you.
That's great. Thank you very much, Emmett. I'm sure you'll agree. I guess, as Emmett said there, the importance of undertaking a risk assessment and evaluating your task before you start it is essential for avoiding manual handling. I guess and that's in order to work, I guess, smarter as opposed to harder. And as Emmett said, not only is it good for the general well-being of workers, but also there are other benefits, not least cost and resource issues as well. So thanks again, Emmett, for that. Our next speaker up, we have Ita Leyden, and Ita is going to introduce us to manual handling assessment charts using the MAC tool. Now, Ita is a consultant ergonomist and a forensic engineer. Ita is also managing director of Leyden Consulting Engineers, who specialise in safety training and ergonomics. Ita Leyden is a chartered engineer, ergonomist, and a chartered member of IOSH. With over 25 years experience in ergonomics, engineering training and safety fields. So Ita's work spans a variety of sectors, not least engineering, pharmaceutical, construction, retail, transport. Consequently, Ita is involved in all areas of safety, from ergonomic design and assessment as a provision of expert witness testimony through to process safety and training, implementation of behavioral-based safety programs and development of safety management systems. So without further ado, I'll hand you over to Ita. Thank you.
Thank you very much, John. Slightly embarrassed over that introduction. However, you're all very welcome to the practical element of this webinar this morning. So today, I'm going to talk you through, I'll give you a whistle-stop tour of using and trying out the MAC tool. So if you haven't downloaded the guide for Mac, now is a good time to do that. So just let me page down here. So I'm going to give you a quick overview of the tools. Frank has already mentioned them, and Emmett has mentioned them also in relation to his example on the Garda station in Galway and how the MAC tool helped with reducing the risk. I'm going to talk you through briefly how you can complete a MAC assessment and the various assessment guides, and you're going to get an opportunity also to try out the tool this morning. So, as again has been mentioned by all of our speakers, that musculoskeletal disorders are a very common occupational injury or health issue, and we can do a lot to prevent them. However, it's very important that when we are trying to identify what area we should focus our improvements on in relation to manual handling, that we focus on the right things. In some instances, it might be the weight. In other instances, it might be the frequency of a lift. In other instances, it might be the posture. And the MAC tool that we're going to talk to you through today helps you to identify which area you need to focus on to reduce the risks associated with manual handling. So the MAC tool, MAC stands for, by the way, Manual Assessment Charts. The MAC tool is part of a suite of tools that has been developed by the Health and Safety Executive in the UK and adapted and basically rubber stamped here by Frank and his team in the Health and Safety Authority. So you have three tools as developed by the HSE in the UK. You have the MAC tool, as I mentioned, stands for Manual Assessment Charts. You have the ART tool, which stands for Assessment of Repetitive Tasks. So that tool is aimed at repetitive tasks that affect the upper limbs. And then we have a separate tool, which is called RAP, and RAP stands for Risk Assessment of Pushing and Pulling. They all are very easy to use. They all use the same type of format in terms of you're following a process flow, you're answering questions, and you have the questions supported by pictograms to allow you to score and answer each of the questions. From worked examples, the HSA, as Frank mentioned in terms of their more recent publication, Risk Assessment for Managing Ergonomic Risks, that contains a few worked examples for each of the tools. So again, you can get a little bit more practice in to develop your understanding and application of each of the tools by going to the hsa.ie and downloading that publication. So I'm focusing today specifically on the manual assessment charts, the MAC tool. And very importantly, what I want to say to you on the MAC tool is there are 3 different MAC guides within the MAC tool. So just to show you, if you have gone to the link and downloaded, you have downloaded this version of the MAC tool. If you were ahead of yourself and you have extra money in the budget, you may have gone and actually purchased, you can purchase the A5 version booklets as well. However, being very pragmatic, I prefer to get the free download. So this is the one I'm going to be referring to today. And what you'll see at on the publication that you have downloaded, that there are different colors across the top of the pages. You have a blue banner across the top, and that blue banner refers to the guidance that you'd be using when you're doing an assessment of a lifting task. Then you will see that it changes to a red banner across the top, and the red banner across the top is for the guidance that you'll use for a carrying activity. And then finally, the guidance document has a teal color across the top, and that's the guidance that you would use if you were carrying out a team handling operation. Importantly, the MAC tool isn't appropriate for all manual handling activities. Specifically, it's not so appropriate for a full risk assessment for patient handling, and it wouldn't be designed for assessing a repetitive task of the upper limbs. So the first thing you need to do if you're using the MAC tool is identify whether or not a more detailed assessment is required. And you have to ask yourself first off, do I need to do a full assessment? So what I'm going to ask you to do is I'm going to ask you, as I flick through this to find my score sheet. My score sheet should be at the back of this, and the reason that it's not there is that I have ripped it off earlier on to show you. So page 19 of 20. So page 19 of your workbooks, you'll see the initial score sheet. And on the score sheet on the right-hand side, you have a number of questions that will help you to identify whether or not you need to do a full, more detailed risk assessment. The MAC can form part of it, but you may need to do a more detailed risk assessment. So that includes things like doing 12 lifts per minute, or things like where the lift involves 5 kilograms for a male while seated, or if the lift involves a large range of vertical movements, of sudden movement of the load. So there's a number of questions there, and if you answer yes to any of those, you can certainly use the MAC tool as part of the assessment, but you will need to consider those additional elements such as the large vertical movements or the risk of the sudden movement of the load. Now, one thing I should highlight here is I've mentioned that these tools were developed by the Health and Safety Executive, and therefore the documentation will refer specifically to the UK's regulations or the UK's documentation. That said, it really doesn't make a huge difference in the overall scheme of things. Both the Irish regulation and the UK regulation both emanate from the European Union. So the requirements are pretty much the same. However, one thing I will mention here is that you'll see on page 19 of 20 there, it says, it references L23 appendix. Now that L23 appendix is from the UK HSE's publication on the guidance to manual handling. But the requirements are what's referenced in that L23 are also referenced in our own guidance to the regulation. So basically, don't get caught up on L23 or when it refers to RIDOR. These tools apply perfectly and comply perfectly with the Irish regulations. One other aspect that needs to be considered in terms of a risk for musculoskeletal health are psychosocial factors, where you might have tight deadlines, lack of control over the work, or high workloads. Importantly, they need to be documented, but you don't rate them and you don't assess them as part of a MAC tool. Again, as with anything, when you're doing an assessment, competence is key. So to assess the effect of tight deadlines and high workloads on someone's musculoskeletal health requires a certain level of competence. So as a MAC assessor, if you become aware of these psychosocial factors, you record them on your sheet here, which is again on page 19 of 20, and then pass them to the powers that be to assess the effect of those on the musculoskeletal health of the individuals that you're assessing. So how do we complete a MAC assessment? Well, we identify the tasks that are either difficult or individuals complain about. Now, within the construction sector, I have no doubt that you're inundated with a choice or spoiled for choice for the number of manual handling activities that are carried out on any construction site, whether it's precast wall capping, concrete panel fencing, whether it's lintels, whether it's glazing, whether it's plasterboard. But obviously start at those that you know are the highest, are most difficult. Then you complete page 1 of the score sheet, which is that sheet I referenced earlier on, and I'll just show you it here again. So page 19 of 20. So do you need to do a full risk assessment? Do you include the details of the activity? And importantly here, from a construction perspective, detail, because the dynamic nature of a construction site and a workplace, ensure here that you capture enough information that explains where exactly or what exact task and location this assessment refers to. And then there's a tick box to identify if the manual handling activity is of a particularly high risk. So that might be either where there has been a reportable accident relating to the task. And again, here you'll see that reference to the UK side of things, and there's a reference there to RIDOR. RIDOR stands for the Reporting of Injuries, Diseases and Dangerous Occurrences, and it's the UK's equivalent of our reportable accidents here in Ireland. So we identify if the task might be of a high risk. So then how do we complete our MAC assessment? Well, importantly, once we've identified the task or activity that we're going to assess, it's very important that we observe. I quite often say that my job when I'm doing manual handling or ergonomic assessments, my job is very easy. I look at everyone else working. And really, that's how, when you gather the information, that will allow you to do an accurate assessment. Of course, recording and video recording and photographs are most helpful here. On the recording side of things, always be conscious of the GDPR elements and ensure that you're complying with the GDPR side of things in relation to capturing individuals on camera or on video. There's also a skill set that needs to be developed when you're recording or capturing information for assessment. Then what you do is you identify which of the tools or guidance documents am I going to use. Is this a lift? Is it a carry, or is it a team lift? So basically, do I go to the blue sections, the blue headed part of the booklet? Do I go to the red, or do I go to the teal? And then as I go through the process flow, what I do is I answer the questions, and for each question, there is a score assigned, and that score is detailed in your guidance document, and each score is associated with a color. And your standard colors of red, amber, and green representing your low, medium, and high risk are used. But MAC also introduces a purple risk. And the most simple way of explaining a purple risk is it's a risk that's off the Richter scale. It's an extremely high risk. So if you come across a particular element of an activity that is identified as a purple risk, well then that surely should focus the mind to reduce the risk of that particular task. There's a very, very high risk of musculoskeletal ill health because of that manual handling activity. So you're going to get a chance to do this in a few moments, but we will take a short comfort break just before I give you an opportunity to try out the Mac tool. So this is an example of a completed score sheet. So with the score sheet, and not to overcomplicate things, you have each of the risk factors, the 9 risk factors in the first column. And depending on whether we are assessing a lift, a carry, or a team, we score and color code each of those risk factors. And there is guidance in relation to how to score and what color to assign to each of those risk factors. And that's what we're going to work through in a few moments. So as you'll see, you have a color band first. So if, for example, we're assessing a lift activity and we're assessing the load, weight, and frequency that a person is lifting, we will put the color under the second column there under lift, and we'll put the score under the fourth column there, or fifth, I should say, under the lift heading. So in this particular example, the color is R for red. So you can go all out and use your color markers, or you can use a platform such as Easy Ergo, which will do the color coding for you. And you assign a color. So I just use R for red, G for green, and A for amber, and P for purple. And I also then input the score. Now, importantly with Mac and with RAP, in fact, if you were using a RAP tool, that your traditional approach to risk assessment is that you calculate the risk and then the final score that you get gives you an overall indication of the level of risk. That's not the case for Mac and RAP. And the reason that it's not the case for Mac and RAP is that any one of those individual risk factors could result in a musculoskeletal injury or musculoskeletal ill health. So each individual risk factor is accounted for separately. Now, there is a total score that is calculated. However, the only reason that we would use that total score is to identify where we need to focus our attention first off. But we're looking primarily at each individual risk factor. And if we have a purple risk, that's where we focus on a purple risk in relation to load, weight, or vertical distance or otherwise. So this is the flow chart for lifting operation. So I'm going to ask you to go to, now so it's a lifting operation, so we're going for blue. And I'm going to ask you to go to page 7 of your workbooks. And on page 7 of your downloaded document, or if you're looking at it on screen, you'll see the flow chart for lifting operations. And all of the HSE suites of tools follow the same type of process. So the first thing you do is you look at the load, weight, and frequency, and you allocate a score and a color code based on the guidance for load, weight, and frequency. You then go to the next stage and you assess the hand distance from the lower back. You then go to C and assess the vertical lift zones, etc. I think you're getting the picture at this stage. So this is the assessment guide for load, weight, and frequency. So for lifting, the load, weight, frequency guidance is on page 3. So I'm going to ask you to go to page 3 now, and you'll see this gives us the score and the color for the load, weight, and frequency of a lifting operation. So what you do is you identify the weight of the load that's being lifted and how often it is being lifted, either during the day or numbers per second, or numbers every few seconds. So let's look, for example, if somebody has to lift a 25 kilogram bag of cement, and they're lifting a 25 kilogram bag of cement twice every hour, so once every 30 minutes. What you do is you look at the load, weight, frequency axis, and you get your 25, and then you go across from that line and you meet the line coming up from the frequency axis. So based on that, I hope you all have identified that for lifting a 25 kilogram bag of cement twice every hour is a amber risk. So it's the color code, color is A for amber, and the score that's assigned is 4. So that is what we will put into our score sheet. So we'll put A under the color band for lift, and then we'll go across to the numerical score on your score sheet, and under the lift of numerical score, we would put in 4. We would then continue to look at the hand distance from the lower back. So what we'd look at here is, hopefully you can see my cursor, but we're looking at the upper arm. And if what you're seeing as part of the task that you're assessing, that the upper arm is in line with the torso, we give it a color of G for green, and 0 is our score. If the upper arm is angled slightly away from the torso, as in the second pictogram there, we're assigning it a score of amber, score of 3 and a color of amber. And if it looks more like the final pictogram there, well, then it's a score of 6 and a color of red. We then look at the vertical lift zones. So here we look at whether or not the hands are generally between the knee and the elbow, or whether or not the hands are in between the knee and floor level, or between elbow and head height. Now, what you'll notice here is that we don't use measurements. We're literally looking at, for an individual or a group of individuals, where is the load being held? And that's what makes this tool quite easy to use. Now, what you'll also notice here is that for this particular risk factor, the red is a score of 3. And if I go back here, the hand distance from the lower back, the red has a score of 6. And the reason that you'll have different numbers for each of the colors is that that's weighted based on the effect or that particular risk factor has on the musculoskeletal system. So the distance that you're holding something from your lower back has a higher contribution to musculoskeletal injury than lifting from floor level. We then assess whether or not there is torso twisting and sideways bending. We then look at any postural constraints, something that will cause the person to modify their posture. If there's none, we'll green 0, 1, some restricted posture or severely restricted posture, we give it a red and a 3. Then we have very good guidance here again in relation to the grip on the load. So we look at whether or not there's good handholds, whether it's your standard pommel grip, and we call that reasonable grip, or whether it is a pinch grip or there's no handles or handholds. Then we also look at the floor surface. Of course, this is going to be particularly important from a construction site perspective. The condition of the floor can have an impact on musculoskeletal health of someone who's carrying out a lifting task. And then we also might look at environmental conditions, so extremes of temperature. And again, here, the weather that we're having at the moment, and getting into your wet weather, you need to consider that as well. So a little bit of a whistle stop, but the objective for today was to introduce you to the tool, and we're going to get you to complete one of the forms in a few moments. But I do think at this stage that you've all been, I've no doubt, very engaged with the speaker so far, so it's time for a little bit of a comfort break. So literally, at this stage, I'm going to say 5 minutes. 3 minutes is what John mentioned, but that'll be gone very quickly. So 5-minute leg stretch. We're going to be kicking back off here at 12:14 on the dot. See you in 5 minutes. So Hugh, if you haven't taken a leg stretch, I'm going to ask you at this stage if you wouldn't mind setting up the video for us. So once we kick off at 12:14, we'll go straight into the video and I'll explain what we're doing to people. Thank you. Okay, you're all very welcome back. So at this juncture, I'm going to show you a video, and this video is of a lifting task. So you're going to be using the lifting guide for this particular walkthrough. And what I'd like you to do is on your score sheets is for each risk factor, follow through the guidance from page 3, and for each risk factor, assign a score and a color code for this lifting activity. So Hugh, if I could ask you to get the video ready to rock and roll there, it would be great, please. And while Hugh is getting the video set up, observation is a very important aspect of the task. So you're going to see this played through a couple of times before you, there we go, let's get that showing there. You're going to see this played a couple of times before you get the information on the weight and the frequency. So I'd ask you all now to start observing and taking notes in relation to this lifting activity. Now, I appreciate that this is, a photocopying box, and many of you may, from the construction perspective, think that this doesn't relate, but of course this does. This could be building blocks. This could be deliveries to your loading bay for loading and unloading. It could just as easily be a box full of ceiling tiles, or a collation of floor tiles. So what you're looking at, obviously, is a person removing boxes from a pallet. You'll see initially that it's 25 kilograms if your eyesight can see that marking on the box. And that's something that Frank referred to, which is recording the weight, and details of the weight and frequency of the lift is very important. Also, to find out if the load is stable or not and whether MAC is suitable. And what you're looking at here then is, you're looking at the worst case scenario. So this would obviously be the worst case scenario when he's taking the items from the lower part of the pallet. So at this stage, you should be working through, we'll come back to the load, weight and frequency, and we'll get that information. But you should also be thinking about the vertical distance from the back, here we have it, great. And the arm posture. So load is 25 kilograms and the frequency is 1 lift every 9 to 14 seconds. So on page 3 of your workbooks, you should be looking at 25 kilogram load lifted every 9 to 14 seconds. And based on that, where or what color and code are you going to give the lift? Put that in on your score sheet on page 20. And now you're going to the next part, which is your hand distance from the lower back. Where is the upper arm relevant to the torso? You're then looking at the vertical lift zones. So is the hand at floor level or above floor level? Based on that, you're giving it a color code and a score again, opposite the row for vertical lift zones. You're then looking at the torso twisting and sideways bending. So we're on to page 5 of your workbooks now. And we're looking at, is there little or no twisting? Is there torso twisted or the torso is bent sideways? Or have we a situation where the torso is both twisted and bent sideways? Based on that, we assign again a color and a score. We then look at postural constraints. And here again, we're looking, is the posture restricted or is it severely restricted? And on that one, put that into perspective. Someone, for example, working in the hold of an aircraft, that would be a severely restricted posture. We then go to our grip on the load. So you'll see here, it's your standard pommel grip. So again, you assign your color and your score for that. Now here next one we have our floor surface, and it's almost impossible to see what the floor surface is like when you're looking at a video. So I can't say how important it is that if you're doing an assessment, you need to be present to physically see the surroundings and the environmental conditions. On a video, you can't see what the floor conditions are like. So in this case, I'm going to assume that the floor is a good floor surface. So you want to score that a 0 and give it a color code of G for green. Then you're looking for environmental factors. So again, here, is there anything that could affect the musculoskeletal health? So we're looking for strong air movements, extremes of lighting, and extremes of temperature. And based on that, we'll either give it a G, an amber, or a red. And that concludes our scoring. So perfect time on the video. Thank you very much, Hugh. We're going to go back to my presentation now, and we're going to compare and contrast the scores that you have assigned. So load, weight, frequency, or 6. So it was 25 kilograms, and as you go over to hit 14 seconds, it's a red 6. Hand distance from the lower back, again, a red 6. Vertical lift zone is amber 1. Now, a mistake many people make here is that lifting on a pallet, they consider floor level. No, it does exactly what it says on the tin. Floor level is at floor level. A pallet is a few inches off floor level. So it's an amber 1. Certainly a red 2 because the individual in question is twisting and sideways bending. There are postural constraints, I would say restricted rather than very restricted here. The grip on the load is your standard palmar grip, that's amber 1. Floor surface we're saying is green 0, and based on what we're seeing there, there are no environmental factors. So what we would look at in relation to this assessment is that we start and we're identifying where do we need to improve things. We need to improve the red colours first off. So we focus on colour first, and then within the colour we look at the score. So the two reds that we need to look at are obviously the load weight and the hand distance from the lower back. So that's what we need, where we need to make improvements. And then we should focus on the trunk twisting and sideways bending, which is our next red, and it's a score of 2. So hopefully you had a fairly good attempt at that, but it's hopefully just illustrated how easy it is to as this system. Now, from a paper-based exercise, you can end up with a lot of paper and color coding, etc. As I say, there are some platforms out there that assist. One which I use regularly is one which I was involved in the development of, and it's easyergo.com, which allows you to carry out the assessments on any handheld device in about 80% or 20%, I should say, of the time of doing it on a paper-based system. So now I'm going to show you the assessment guide for carrying operations. So we're going to the red banner across the top. Now, you may see that a lot of lifting involves lifting something, or I should say manual handling involves lifting something and then carrying it, in which case we have two separate assessments, because lifting is one assessment and carrying presents slightly different risks. So as you'll see on the assessment guide for carrying, it's on page 12 of your workbooks. Again, we're going to start with load weight frequency, work our way through to hand distance, asymmetrical torso, postural constraints, and we're going to work through that and our guidance. So I'm going to suggest that you go to your beginning of your guidance on page 8. And you'll notice that, well, we're covering a lot this morning, so you may not notice, but I'm going to tell you that the guidance for load weight frequency for a carrying operation is slightly different to the guide weight frequency for a lifting operation. So that's why it's important that you're using the first or the correct guidance as part of the MAC. So again, that's based on the weight and how often the weight is being lifted. Hand distance from the lower back, same pictograms, no particular difference here in terms of the scoring. Now, this is unique to the handling or the carrying side of things. So now we score where the load is being carried relevant to the upper torso. So is it in front? It's a green 0. Is it to the side? Or is it two-handed to the side? In which case it's a red 2 that we score. And of course, from your score sheet side of things, on your score sheet, we're now following the carry, or we'd be filling in the carry columns under colour and scoring. Again, postural constraints, the same considerations as for lifting. Grip on the load, same considerations as for lifting. Floor surface, same considerations. But now we have to include another risk factor, which is the carry distance. So how far is someone carrying the load? And here, you're not expected, and that's one of the joys of these tools, is you're not expected to start getting out measuring tapes. So you can step it out to say, is it about 2 or 4 meters? Is it about 10 meters? So stepping something out or estimating is perfectly okay in this situation. Another thing that we're looking at in terms of carrying are the obstacles that someone has to get around while en route. So here we're looking, very importantly, we're looking at the types of obstacles rather than the number of them. So if somebody has, there are 3 trailing cables en route on someone's route that they're carrying an object or carrying out a carrying task on, well, we only count that as one obstacle, even though there's 3 of them, because it's only one type of obstacle. So again, here, you're only going to see obstacles en route if you're off your backside, you're down in the area, and you're looking at the carry being carried out on your construction site. The environmental factors are the same as for your lifting. So we have 3 additional considerations here. And as you'll see on your score sheet, where a consideration isn't, or a risk factor isn't applicable to the type of lift, they're blanked out on your score sheet. So it's your turn again. I'm going to ask Hugh if you wouldn't mind getting it ready there for me, please. And again here, I'm going to ask you to observe first off and do a very quick down and dirty scoring and of this carrying activity. So in our carrying operation, we'll see our willing volunteer here continuing from the end of the conveyor and lifting the boxes off the end of the conveyor. So the things to observe here are how he's carrying it, the hand distance from the lower back, the vertical lift distance. You're looking at the obstacles. You're also looking at any postural constraints that he has to try and get around. And as we go through, we'll observe it for a couple of actions or cycles, and we will get the information as to the frequency of the lift. We know the lift is 25 kilograms. So again, remember you are using the carrying or operations assessment guide, and it's the load weight frequency on page 8. So again, just another point of note is that as he is going through the door at the end, he's lowering the box. Now, that is a separate assessment. Again, that lowering is the same as a lifting assessment. So you'd be doing 3 assessments typically here. You'd be looking at the lifting to put on the conveyor in the first place. Then you'd be looking at the carrying operation. And then you're looking at the lowering operation to lower the box at the end point. So here we have a 25 kilogram load lifted every 20 seconds approximately. And I think that approximately is more than important. So look at your score, at your load weight frequency, get your 25 kilogram load and go across to 1 every 20 seconds and give your score and your color code. Again, I'm going to ask you for your hand distance from the lower back here. So remember here now we're looking at the graphic and we're looking at the arms alignment to the torso. So give that a score. Now we're looking at where the load is being lifted. So we're at asymmetrical torso or load number or C there. So give that again your score and your color code. And now we're looking at postural constraints. So here we're looking at, is there anything that causes the worker to modify their posture? And score accordingly. We're looking at the grip on the load. Again, look at your pictograms. And we're also looking here at the floor surface. So we have some sight of floor surface there. So again, I'm going to tell you the score there is, we're going to put it as a green and 0. And now we're looking at the carry distance. So again, the carry distance, you can count the steps, you can approximate it, and that's perfectly okay. And we're looking at our second last now, we're looking at our obstacles en route. So what you're trying to do is identify what obstacles does he have to maneuver around. And the number of them, not the, sorry, the number and the type rather than the number of obstacles. And then we're looking to say, are there any environmental factors here? Are there extremes of lighting? Are there wind conditions or extremes of temperature? Perfect. Thank you very much, Hugh. I'm going to ask you to You might get me back to my presentation again, and we'll do a quick overview to see how we all got on in that assessment. So load weight frequency, again, I'm no doubt you all got amber for there. Now, the hand distance from the lower back, I would say that there's a few who have scored this. Let me just get to my own score sheet here. I would say that there's a few who have possibly put the hand distance from the lower back as amber and 3. And the reason that it is a green and a 0 is that the arm is in line with the torso, but it's held out to the side. So hopefully you can see me doing that there. Now, we're capturing that element when we assess the asymmetrical trunk and load risk factor. But in effect, if I was to turn sideways, you'll see that even though my arm is out to the side, it's still in line with my torso. So it's not here and it's not here. It's in line with my torso. So therefore, that's why the hand distance from the lower back is a green 0. Then the asymmetrical trunk load, that's obviously been carried to the side, so it's an amber 1. Now, postural constraints, you'll see that he had to duck underneath the pipework. So that's where we captured that pipework. We don't call that an obstacle later on. We've captured the pipework already in a postural constraint. He's adjusted his posture to get underneath the pipework. Grip on the load, amber 1. Floor surface, we said, is green 0. And the carry distance, an estimate between 4 and 10 meters. So an amber 1 is what we're putting that one. And the obstacles en route, we have 2 different types of trip hazards. So it's an amber 2 there, and no environmental factors. So again, I'm sure many of you were flying along with that, and some may have questions in relation to the exact scoring, but that's developing your competence in carrying out the assessments. There's lots of opportunity for practice runs. If you can go onto the HSA website, and you'll get a link there to the HSE's website, where there are a number of other examples worked out where you can develop your competence of using these tools. We're not going to do an exercise on this, but I'm going to just talk to you about the assessment guide for team handling operations. So this is on page 17 of your workbooks. You have the teal banner at the top, and you have again a process flow that you'll follow in answering questions. So the first thing for a team handling operation, this is where you have 2 or more carrying out a handling task. We have a load weight. So here, depending on the number of people carrying out the load, we need to assess the load weight and how many people are carrying the load. And this, I think, is a very important or a very common assessment that will be used on the construction side of things, whether it's 3 or 4 carrying an RSJ across a site, or otherwise. So just to give you the example here of Emmett's example earlier on of the cladding. So that cladding was 104. One of the sets of cladding was 142 kilograms being lifted by 2 people. So 142 kilograms being lifted by 2 people, where would you put that risk in relation to the load and weight? So as you'd see there, it's actually 2 people lifting more than 85 kilograms presents a purple risk, and it gives a score of 10, which gives it a very high chance of musculoskeletal ill health. So as Emmett correctly put up his hands and said, yeah, they were wrong, and the MAC tool helped them to identify where they needed to improve, and we heard the rest of their success story in relation to their improvements. Hand distance from the lower back, again, we're looking at the upper torso and the arm relation to the upper torso. But when we're looking at a team handling operation, look at the smallest person or the shortest person, or the worst case scenario of what you're seeing. So if you have 3 people lifting, one has got their arms nicely tucked in, and the other is their arms way out here. Look at the person and score on the basis of the person who's got their arms furthest away from their torso. Similarly with the vertical lift zones, if the 2 or more individuals who are carrying out the handling operation are not evenly met in terms of stature, one is holding it above the head while the other is at shoulder height, you're assessing the person who's carrying above the head. Similarly, with torso twisting and sideways bending, you're looking at the worst observation that you have of those involved in the team handling operation. Postural constraints are similar, grip on load is similar, floor surface is similar, carry distance is similar, obstacles en route is similar. However, we now have another contributor to potential musculoskeletal health, which is the communication side of things and the coordination and control. And as I'm sure you're all aware, that if two or more are lifting or carrying out a handling operation, it's critical that there is communication and coordination, because if one starts a handle before another person is ready, one is all going to get the whole load, or the load could result in someone suffering musculoskeletal ill health because of that lack of communication. So again, here what you're doing is you're observing to see, is the lift being controlled? Is there coordination and communication between all those involved? And the environmental factors, again, are similar to those which you would have had for the lift and for the carry guidance or the carry tasks. So in terms of MAC, you consider, is a manual handling assessment needed? And again, here, if it's kind of less than 3 kgs or falls within the guidance, you're familiar with guidance with the HSA, the outline of the man or the woman and the weights, holding them away from their body and up high, you have 25 kgs, 5 kgs, 10 kgs for males. That is the guidance which indicates that 95% of the male population wouldn't be at risk of musculoskeletal ill health if their weights and are being carried, the weights that they're carrying are within that guidance. Now, of course, as with the HSA guidance as well, the frequency comes into account, and if it falls outside that guidance, well then a MAC assessment would be justified, and I would suggest not only justified, recommended. Then you decide whether or not it's a full assessment, or whether MAC on alone is okay, or you need to do MAC and more. And then you decide whether it's a lift, carry, a team, or indeed 2 or more of those. And if there is a lot of different lifts of different weights and frequency, as you might get in a distribution center, there is a bolt-on to the MAC tool, which is called a VMAC, a varied MAC, which can help with the assessment side of things. But that again, you can get the link to the HSE's website from hsa.ie. But I would say get a handle on MAC first off, and once you're familiar with MAC, then depending on the application, you may need to go further with the VMAC or otherwise. Most importantly, understanding that musculoskeletal ill health, there's an awful lot that can be done to reduce the risks of that happening in a workplace, particularly in construction. And the objective of carrying out MAC, or indeed using RAP or ART, is to identify where the risks are present and where you need to focus your attention for improvement. On that note, I'm going to hand you back to John, and as requested, I'll remind you, if you have a question, please put it into the Q&A section, not the chat box section of the webinar. Thank you very much.
Thank you, Ita, for such an informative presentation, and not to mention the practical demonstration of the MAC tool, which is really informative. We'll now have an opportunity to review questions raised. So this will be kindly facilitated by Barry. So if you haven't had an opportunity yet, please add your questions using the Q&A window on your screen, and please refrain from using the chat function. So over to you, Barry. Thank you.
Thank you very much, John. And I see you've answered this question in the Q&A section, but I wonder, can you expand on it a little bit? It came in from Paul, and Paul was asking about the good examples of collaboration between all the stakeholders, such as the HSA, suppliers, etc. And have they bought into this? Could you expand on that a little bit?
So certainly in terms of the project that I showcased there, or the case study, the majority of parties bought in. So the subcontractor, being the main contractor, ourselves, bought into it, and the HSA very much bought into promotion of this through us. Probably not so much the client and the PSDP, to be quite honest with you, at the time. And they said, you price the job, you should do it safely. And I suppose in one way we discovered or we undertook it in a safe way, and their attitude was, well, why didn't you do that from the very start? Whether rightly or wrongly, that was the way that happened. Bringing it forward from that job, certainly our own design and build projects, we've had large focus on it, and ensuring that stone cladding is identified as a high risk or as a particular risk actually on our projects through Schedule 1 of the construction regs. That's the way we're defining now on our jobs. And with that, we in design and build, we can liaise with our design teams very early and get a change. And we did that. I mentioned it on one of our jobs in Galway where we're doing it. However, on other jobs, that's the way it was designed, and we implemented the mechanical processes on it. And there was nothing we could do to change the client on that. If we could get in earlier, I think we probably would get better buy-in. And I know I'm probably speaking for Frank now, but I do believe that the HSA are kind of focusing in on this and trying to have a liaising process and a learning tool with PSDPs and clients, so that it will make it a bit easier for us to be able to do it going future. I don't know if Frank wants to add something to that.
Yeah, it is an area, a deficit that needs to be addressed. I suppose the development of kind of competence and awareness around risk assessment tools and communication of that with the design, the designers and the PSDPs. I think there's a lot of work we as an authority need to do around that, so that we can, so these problems don't happen on site. Well, they should maybe mitigate those risks as much as possible at design stage. So there is a body of work to be done in that regard from our point of view as well.
Thanks very much for that, Frank. I've a question here about the MAC tool, and that is the question from Emma. And Emma's asking, where do you start to see if a MAC tool is required, and what publications or form do you use?
So I'll take that one. So I would say start by going to the HSA's publication on ergonomic risks, the one that Frank mentioned earlier on, and I referred to, and that gives you some guidance. And from there, you can also, on the HSA's website, you can get a link to the hse.gov.uk's and guidance on how to use the MAC tool. So that's contained in that link as well that we all received to this booklet here. So what I'd say is start by using the HSA guidance, and then from there establish if a MAC assessment is required, and then use your guidance document for completing a MAC assessment.
Thanks.
Barry, I might just I suppose on a practical side, on the construction site, and try and give a bit of experience or what we have been doing on our sites is rightly or wrongly, but where we are seeing loads which are the old rule of thumb in a sense over 25 kg, if that's what kind of Emma's getting at there in terms of where to start to see the introduction of the MAC tool. Certainly that I believe is a key point. The heavier materials that you're looking at, whether it's a 1-person or 2-person guiding or getting guidance from about 25, 50 kg, that's where you should be introducing MAC tools. Exactly. Or yes. A lot of repetitive work. You see there that the first 2 things that we're looking at is weight and the amount of times you're doing it in an hour. So if you're seeing a guy is carrying a load for a certain amount of times, that should be triggering you. Well, let's start assessing this on the MAC tool and see where we go.
Yep.
Okay, thanks very much for that. I have another question here for Emmett. And Emmett, the question is, how do you manage the relocating of the steel structure you used to attach the Outback lifting machine as the cladding went up?
Yeah, I possibly, I suppose I did do a quick answer to this on the text element.
You did, yeah.
Possibly, I just said it in terms of Andrew there, possibly the later slides confirm this with the higher bracket system used as we got nearer to the parapet. I think that's kind of what he's leading towards. So we had the new adaptation where we went away from the beam or the bracket system that was just at the height of the parapet, that we had the extension that went up above the parapet. I think that's what he's meaning. If I'm not picking it up right, he might come back and clarify the question maybe a little bit. But that's how we got around that.
That's great, Emma. Thanks, Frank. That's all the questions I have here at the moment, Frank. I want to hand it back to you if you wish.
Sorry, can I? This is Hugh here. I just noticed a question here in the chat that might get lost, so I thought I might ask it on the behalf of Shane quickly. Shane wanted to know, how difficult was it to bring in the changes, and how long did it take? What engagement tools did you use? And I think that refers back to your presentation, Emmett.
Sorry, Hugh, could you just read that question again for me? Apologies.
It's a gentleman in attending the seminar, Shane Quigley. He just wanted to know, how difficult did you find it to bring in the changes that you found in your assessment of the situation?
It wasn't too difficult for a couple of reasons. Number one, we had health and safety on our back. So that was educating the minds, and it was straightening us up to get this going. There was a bit of research, and there was plenty of meetings between the subcontractor. There was plenty of Googling to see what alternative means is out there. But that all happened fairly quickly then after that. So once we knew what we needed to put in play, we probably were on a go slow for about 2 weeks, to be quite honest with you. And then it was slowly when we started initially, just to make sure everything was right. Then we spotted, in terms of that loading bay, we wanted to make sure we had everything right. So we introduced a new element to it. So by the time we got to where we are at the moment, and the full process being, we were probably talking a month, but we were probably down, not working for probably a week and a half to 2 weeks. But everyone bought into it. The subcontractor bought into it as well. So it made it easier that way.
Thanks for you for picking up on that as well. Appreciate that. That's all the questions we have for the moment. So I'll hand back.
Right. Well, I think it leaves it to me really to, well, firstly, to thank today's presenters, namely Frank, Emmett, and Ita. Additionally, sincere thanks to all working in the background who've not necessarily seen, but Hugh Jordan and Barry Devitt, both of the HSA. On behalf of all involved, I'd like to thank all of the participants for their interest in the topic. We hope you found it useful. And as a reminder, today's event was recorded, so it will be available for future reference through the HSA website next week. And indeed, Hugh has shared a link to where that will be. Before we close, I'd like to remind everyone that next week, that's week commencing the 25th of October, is Construction Safety Week, but it's also European Safety Week, and the theme of which is Lighten the Load, as illustrated by Frank's backdrop. And both of the campaigns have free web pages with free resources, be it videos, toolbox talks. So please, do avail of them. Get involved. It's free to do so, and it's also an opportunity to showcase the great work that you folks might be doing on the ground in terms of ensuring a focus on safety, health, and well-being. And of course, be sure to tag the HSA and CIF across social media, and we'll endeavour to support. So unless there's any further comments, I'll call a halt to it, Hugh, if you wouldn't mind.